A normal city street carries thousands of vehicles a day without issue, right up until the moment the pavement violently gives way, swallowing everything on the surface into a deep, dark void. Heavy trucks, harsh weather, and constant traffic usually take the blame for road damage. We imagine asphalt wearing down from the top, but the most catastrophic failures actually start from the bottom up. A city street operates like a thin bridge. Underneath that asphalt lies a highly complex foundation of crushed rock, compacted soil, and utility lines. When the earth supporting that foundation washes away, the heavy pavement is left suspended in midair. The road becomes a rigid trapdoor over an empty abyss. The fatal structural collapse happens quietly, in the dark, months or even years before a single crack appears on the surface. To see how the ground disappears, we must look closely at the soil itself, a densely packed matrix of rocks, sand, and microscopic clay particles. Think of it like a tight game of Jenga. The large rocks provide the primary load-bearing structure. The tiny, fine particles pack into the gaps, providing the critical friction that locks the entire matrix in place. The trouble begins when moving water enters this environment. A leaking sewer main or a simple hairline fracture in a concrete underground pipe introduces a steady, pressurized flow. This sparks a localized tug-of-war. The friction of the packed soil tries to hold the particles tight against the hydrodynamic drag of the escaping water. If the water's drag force overcomes that internal friction, the soil begins to move. The earth supporting the street loses its grip. In the first phase, suffusion, flowing water strips away fine dirt particles. Next, during piping, the widening gaps link up into continuous tubular channels. Accelerating water then carries away larger material, carving out a massive, cavernous room directly below the pavement. Above ground, commuters continue to drive over the area at 60 miles an hour. They are completely unaware that the only thing holding up their vehicles is a few inches of asphalt bridging an empty chasm. The urban underground is famously unpredictable. Recently, a massive tunnel boring machine beneath Bengaluru breached an enormous, undocumented pile of buried garbage. It highlights exactly how unstable and unknown the layers beneath our cities really are. A cave-in represents the final, inevitable mechanical failure at the end of a relentless timeline of invisible microscopic particle loss. To stop the collapse, engineers have to find these hollow spaces before the asphalt snaps. Excavating thousands of miles of urban roads to check the soil is physically and financially impossible. This diagram shows how ground-penetrating radar solves the access problem. A surface cart fires high-frequency electromagnetic pulses downward through the pavement. Whenever these waves hit a sudden empty space, they reflect back to the surface to map the boundaries. A single municipal survey generates thousands of 3D radar scans. Relying on human inspectors to manually spot subtle visual anomalies in miles of raw data is tedious and highly prone to error. Researchers are now deploying deep learning AI models to read the scans. Using object detection frameworks like YOLO, these algorithms scan the radar imagery and instantly flag the exact geometric signatures of underground cavities. Once the AI pinpoints the exact location of the void, repair crews perform targeted subterranean surgery using a technique called compaction grouting. Crews drill a small access hole through the pavement and lower an injection pipe. Then, a highly pressurized, thick paste made of cement and aggregate is pumped directly into the empty cavern. Because the paste is highly viscous, it expands outward like a rigid balloon. This perfectly maps the shape of the void and forcefully compacts the loose, eroded soil surrounding it. That intense physical pressure reverses the mechanical damage caused by the internal erosion. It restores the density of the earth and provides a solid base for the asphalt above, all without ripping open a street. Every time you drive smoothly across a city block, your safety relies on a continuous war fought in the dark by structural engineers, electromagnetic radar beams, and machine learning algorithms.